Greetings, math magicians. Today what we're going to look at is solving a system of linear equations, and we're going to use elimination. So another word for that is linear combination. So some books will say linear combination and some books will say elimination. I will use them interchangeably in this lesson. Okay, now you may recognize these steps as some of these steps are actually the same as the substitution. So for example, in substitution, we solve for a variable, we substitute it back into any of the equations, and we also do a check. So the new ones here are going to be steps 1, 2, and 3. So the first thing we want to do is to align all the terms. So by way of an example, if I gave you 3.1415 plus 1.618, and I wanted you to add them together, one of the first things you would do is write down 3.1415, and then you would take this number, the 1.618, and you would line up the ones with the ones, the decimal with the decimal, the tens, the hundreds, etc. And notice then there's a ghost term here. So now when we add them together, things are lined up accordingly. Well, it turns out that's one of the first things we're going to do, is that we want to make sure that our x's are lined up, our y's are lined up, our equals are lined up, our constants are lined up. And it doesn't matter the form. This happens to be standard form, but they could both be slope-intercept form or some other random form. So step number 1, we're going to make sure the terms are aligned. Step 2, we want to get opposite coefficients, or excuse me, opposite terms, because remember, when you add opposite terms together, for example, 3x plus negative 3x, you're going to get 0. Or if you add up 10y plus a negative 10y, you're going to get 0. So that's the key here, is that we're going to get opposite terms, so when we add them together, they're going to end up dropping out. So hence the term elimination, because adding together, combining my linear equations, are going to eliminate the term. Then we're going to solve for a variable. We're going to substitute that value into any of the equations from above and solve for the remaining variable. And lastly, we're going to check. So let's walk through step by step. Example A, then you can do problem number 1. Notice that here, steps 1 and 2 are done for us. Number 1 is aligned. We see these are all aligned perfectly. Now step 2, we also see we have opposite coefficients. These two are opposites, so we're all set. So step 3 simply says I'm going to do my linear combination. I'm going to add things together. So when we add these together, my 3x's drop out, and I'm left with 6y equals 12. And now, so that's step 3, done. Step 4, I need to solve for that variable. So y is going to give me a 2. Step 5 simply says I'm going to substitute that value into any of these two equations up here. A lot of people like to choose the top because there are no negatives to manage, so I will do the same. So here is my 2, and so I substitute that in for y. So 2 times 2 goes there and equals 7. So here I get 3x plus 4 equals 7, 3x equals 3, and x equals 1. So step 6 is now a check, and I'm claiming that 1, 2 is my solution. So how do I verify that? I'm going to take the 1, 2, plug it here and here, and then here and here, and to make sure that it works. So 3 times 1 plus 2 times 2 equals 7, and I'm not sure about that yet. So 3 plus 4 equals 7, 7 equals 7, so we see that it works for the first equation. Now let's go to the second equation, negative 3 times 1 plus 2 times, 4 times 2 equals 5, question mark because I don't know. So negative 3 plus 8 equals 5, and indeed it does work. 5 equals 5. So now I'm going to commit to it by putting a circle around it, and we see that 1, 2 is my solution. So take a moment here to practice over here. I do want to point out that steps 1 and 2 are done for you. Things are already aligned. We see everything's aligned, and we also have opposite coefficients donated to you for free. Down here at number 2, I want you to be aware that steps 1 and 2 are also done for you, but instead of canceling out the x's, you're going to cancel out the y's. And of course, it doesn't matter which ones you do cancel out. Your job is to get rid of one of them. So now we're on the next page here, and we're looking at example C. Example C has this. Now notice that step 1 is to align, and step 1 is done. Here are my x's, here are my y's, here's my equal, and here are my constants, all set. So step 2 requires me to have opposite coefficients, or excuse me, opposite terms. But I currently don't have opposite terms. So in order to get opposites here, one of these or both of these need to change. Same thing here. So I need to decide which one's easier. So I'm looking for, effectively what I'm looking for is a common multiple, but we often just consider the lowest common multiple. Well, the LCM of 2 and 4 is 4, so that means I only need to change this one because that's already there at 4. The LCM of these two is 15, so this one would have to be multiplied by 5, this by 3. So that looks like more work than I want to do. So in this case, I'm just going to multiply the top by 2. And what that's going to do is give me the 4x that I want for the top. And I do need to distribute that all the way across. So 2 times 2x, 2 times negative 3x, and 2 times 4 to give me this new equation. The bottom one remains the same. And notice my goal has been met for step 3 is I have opposite, or step 2, I have opposite terms there. And the most important thing is that the x is here. I could have done the y's, but I didn't want to. It turns out there's opposites here too, but that's not going to, that's not one of our goals. All right, now, so step 3 is I'm going to combine them to hence my linear combination. The x's drop out here, and I'm left with negative y equals 0, and take the opposite there to get y equals 0. So there's my step 4. Step 5 says I need to substitute that in somewhere, and again, it doesn't matter which one. I'm going to choose the bottom one just because I didn't before. So negative 4x plus 5 times 0 equals negative 8. Negative 4x equals negative 8, and x equals 2. So I'm claiming that my solution is 2, 0. So I just need to do a quick check for both of those. And in checking here, I get 2 times 2 minus 3 times 0 equals 4. And simplifying things work out pretty well. 4 equals 4, and that's a check. Negative 4 times 2 plus 5 times 0 equals negative 8. And the simplifying negative 8 does equal negative 8. And we checked out. So as you look at number 3, what do you think you're going to multiply? Well, you actually have options here because the top one can multiply by 3 to get opposites here, or the bottom one can multiply by 8 to get opposites there. But we might want to avoid the 8 here because 8 times 27 gets to be larger and a little bit more tedious. So work through that one, and I suggest multiplying the top by 3, like so. So go ahead and finish that one up. Now, when we look at D here, what we do notice is that we, again, if we're looking for a common multiple, or more specifically the least common multiple, these two here, I'd have to get to a 6 here, so multiply this by 3, but I have to get to the opposite here, so I have to multiply this one by a negative 2. Notice I already have opposite terms here, excuse me, opposite signs. So if I multiply this by a 7 to get a 42, this by a 6 to get a 42, that could work too. Some people might not want to do that because of getting larger numbers, but I'll go ahead and do that because I already have opposites and I don't have to deal with negative numbers much. So if I multiply the top by 7, I get 14a plus 42z equals 28. Now, multiplying the bottom by 6 will give me 18a minus 42z equals 36. Now I'm going to add them. So let me walk through again my steps. Step number 1, things were aligned here. So step 1 is done. Step 2, I multiplied to get opposite terms. Step 3, I'm going to do the linear combination component. Notice the z's drop out here, and I'm left with 32a equals 64. Divide both sides by 32, and a is 2, and that's my step 4. Step 5, I need to take that substitute that in somewhere. Again, it doesn't matter which. In fact, this 2 can go into any of these. I can go here, 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 or here. I'm going to choose one of these because they're smaller numbers to manage, plus they're the original problem, which means I have less chance of making a mistake. Substituting in, I get this. 4 simplifies there. Then I'm going to subtract from both sides, and z is equal to 0. Now I just have to do a double check. I'm claiming that 2, 0 is my answer. Why did I choose the 2 first? Well, I went alphabetical. A and Z, so 2 and 0. I could have just listed it as answers instead. If you didn't want to write it like that, you could have said A is 2 and Z is 0. Either way is correct. All right, so now I just do a quick check. And as you can see, things check out fine. So now I commit to my answer, and 2, 0 is the solution here. All right, the last type of problem we're going to look at is part E here, where things are not aligned and things aren't, I don't have opposites. Notice I have a 2x and a 3x. I have a 5y and a 5y, but this 3x, by the way, is on the not the same side, so it's got to move over. So I might want to do 2 things at once. I might want to multiply things. So if I multiply this one by negative y, because then the 5y's will be positive, negative 5y and positive 5y. And at the same time, I'm going to align by subtracting 3x from both sides. So in doing that, I get negative 2x minus 5y equals positive 11. Take the opposite. And then this one, when I subtract the 3x from both sides, I get negative 3x plus 5y equals negative 21. So step 1 and 2 were done at the same time, aligning and multiplying. Step 3, I'm going to do my linear combination and add them together. And clearly we see the 5y's drop out. So I'm left with negative 5x equals negative 10. So solving that, step 4 gives me x is positive 2. And now step 5, we want to put that into one of the original. I'll put it on the top there. 2 times 2 plus 5y equals negative 11. 4 plus 5y equals negative 11. 5y equals negative 15. And y equals negative 3. So step 6 is the check. And running through the check, and we see that both of these work out, so 2, negative 3 is the solution. So take some time to practice those ones. The last thing we want to walk through is an application, and that looks like this. In one day in the National Civil Rights Museum in Memphis, Tennessee, they admitted 321 adults and children, and they collected $1,590. So the price of admission is $6 for adults, $4 for children. So how many adults and how many children were admitted to the museum that day? So the first unit that we have is dollars. We see that we're adding things up. We have the cost, the total cost here. The other one that we have is the total number of people. So the total number of people. So that's going to be the basis of my 2 equations. So I need to know what I'm finding. A is going to be the number of adults, and C is going to be the number of children. Okay, so when I say A plus C, the number of adults plus the number of children is going to be 321 total tickets sold. Now I'm going to take the unit price for each one, $6 for the adults, $4 for children, and that's going to add up to $15.90. So that's going to look like this. 6 times A is the dollar amount, 4 times C is a dollar amount, and the total price is the dollar amount. So I do have my system now. So step 1, I'm already aligned, so that works out well. So step 2 is I need to multiply things in order to get opposite coefficients, or excuse me, opposite terms. And it doesn't matter which one we do. You can multiply by negative 6 to cancel these out, or negative 4 to cancel these ones out. So I'll just go with the negative 6 to begin with. So there's my multiplication. Step 3 says I'm going to combine them. And we notice that the 6a's drop out. I'm left with the negative 2c is equal 336, don't forget the negative, and C tells me how many children I have. that came is 168 kids. Now I'm going to take that, and it's easiest just to put it back into the top equation there. So A plus 168 is equal to 321. So the number of adults that came is going to be 153. And now just run through a quick check. And so our conclusion here, and we're going to bring it back into the real world, is the number of adults. Oops, excuse me, we can write it down here. There were 153 adult tickets, and there were 168 children tickets sold. And that's going to be my solution. All right, there's another practice one down here for you, and then you can work on the assignment.